Hello, good people of pre-calculus. Today we're going to be talking about lesson number 3 in Unit 6, which is going to be connecting what we did over the last 2 classes. You'll recall that in lesson 1 we talked about trig, and in lesson 2 we talked about angles, and today we're going to see how they relate. Let's begin. We need to start by talking about 2 of my favorite triangles. The first one is this. Imagine that we have a right isosceles triangle, and let's assume that the hypotenuse has a measure of 1. Well, if it's isosceles, doesn't that mean that these 2 sides have to be the same length? So if this is x, this side right here would also be x. Also, if it is isosceles and right, this is 90. These 2 angles, this one and this one, don't those have to be the same? So those are both going to be 45 degrees. All right, so where does that get us? Well, we want to figure out what the length of these 2 sides are. So what we're going to say is that by Pythagoras, if you take x squared and you add x squared to it, you're going to get the hypotenuse, which is 1 squared. And then let's simplify here. X squared and x squared is 2x squareds. And then let's isolate the x squared by dividing both sides by 2. So x squared is equal to 1/2. We're going to root both sides. We get that this is x. On the other side, this would be the square root of 1 over the square root of 2. And I want you to rationalize that. So we're going to multiply this by roots of 2 and this by roots of 2. And we arrive at the 2 side lengths are roots of 2 over 2. This is called a 45-45-90 right triangle. Now, how is that helpful to us? Well, let's come down here for a second. 45 degrees in radians would be pi over 4. So anything that you would find for 45 degrees is going to be the same as pi over 4. Once again, I'm getting that from right here. And let's talk about the sine, the cosine, and the tangent at that angle. The sine of 45 degrees would be the opposite over the hypotenuse, which is roots of 2 over 2. The cosine of 45 degrees would be the adjacent divided by the hypotenuse, which is roots of 2 over 2 divided by 1. The tangent of 45 degrees would be the opposite divided by the adjacent, roots of 2 over 2, divided by roots of 2 over 2 gives us 1. Okay, now we're going to do the same thing for 2 more special angles. Those are going to be 30 degrees and 60 degrees, and we're going to get those right here. So this is half of an equilateral triangle. What I want you to imagine, let's see if I got a pencil here, is here's the rest of the equilateral triangle. Lightly drawing this in pencil. Well, we know that these 1, 2, 3 angles here all have to be 60 degrees. So I'm just going to label this one, because this is the one that's inside the triangle we care about. There's 60 degrees, 90 degrees, and that means that this one right here is going to have to be 30 degrees. 30 plus 60 plus 90 is 180. Well, we can use this to find the measures of boom, boom, and boom. Let's start with x. X is actually going to be the easy one because you can see that this and this are equal to each other. Now keep in mind that this is an equilateral triangle. So if this distance right here, our hypotenuse is 1, then this distance right here is also 1. Cut that in half, and we're left with 1/2 right here. So we got x, let's go get y. Y squared plus the other leg is a half squared is equal to 1 squared. So y squared plus a quarter is 1. So y squared is equal to, subtract 1/4 from both sides and you get 3/4. Root, and you get that y is equal to the square root of 3 divided by the square root of 4. We know the square root of 4, that's 2. Okay, so here we go. Now that we know this information, let's solve some of this. So 30 degrees is the same as pi over 6, and 60 degrees is the same as pi over 3. We learned about this last class. I would memorize these 3 guys. This one, and this one. Just know those. It'll make your life easier. Sine of 30. Here's 30. Sine is opposite over hypotenuse, so that would be 1/2. Cosine of 30 would be adjacent over hypotenuse, so that's roots of 3 over 2. Tangent of 30 would be opposite, which is 1/2, over adjacent, which is roots of 3 over 2. You can simplify this by multiplying by 2 and multiplying by 2, which is going to give you 1 on top and square root of 3 on the bottom. And if you rationalize that, you'll get roots of 3 over 3. Okay. This one's going to be very similar right here. Let's do 60 degrees. So here's 60 degrees. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that'll give us roots of 3 over 2 divided by 1/2. Same game, multiply by 2's here, and you end up with roots of 3 on top and 1 on the bottom. So that whole thing is just equal to the square root of 3. Okay, good stuff, ladies and gentlemen. Now let's go to the unit circle. Unit circle. Unit means that the radius is equal to 1. Unit is just another way of saying 1. So on this circle, which is centered at the origin at 0, 0, if I was to draw in some random radius here, we would know that that radius has to be 1. And when we do that, what we're interested in is this point right here, x comma y. How is x comma y related to the angle that we get right here in standard position? And the answer is that it's connected by trigonometry. Check it out. If you drop a perpendicular to the x, then this distance right here is your y value. And this distance right here is your x value. Therefore, the cosine of the angle would be equal to the adjacent over the hypotenuse, which is x over 1, and the sine of the angle would be equal to the opposite over the adjacent, which is y over 1. So in other words, the x value of this point right here on the unit circle is just equal to, right there, the cosine of the angle. And the y value is just equal to the sine of the angle. There's the unit circle. All right, now with that in mind, boom, 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 boom. Look down here. Here's the unit circle with a whole bunch of measurements in there. You'll notice that it's hitting 30 and 45 and 60, the three big angles that we talked about on the last page right here. And you'll notice that the X and Y values that we're getting here and here and here and here, those are the numbers that we came up with for our sine and our cosine. Last thing that you want to notice is that in this quadrant right here, we have some negative values, and in this quadrant, we have all negative values, and in this quadrant, we have some negative values again. So let's just remind ourselves that when you are in quadrant number 1 right here, X and Y are both positive, but in quadrant number 2, X is negative. In quadrant number 3, both X and Y values of points are negative. And in quadrant number 4, the X value is positive, but the Y is negative. All right, so that was a long setup that finally brings us to the problems that we want to solve. And I'm going to do that in the next video.